All right. So in the previous discussion, I talked about independent samples t-test, wherein if you would wish, it's a parametric tool or test that could be used to determine if there's significant difference, whether there's a significant difference on the means of two independent groups. But right now, there are certain instances, for example, if you could gather, say, data from your respondents twice, and let's say you wish to compare if there is a significant difference between paired data. For example, let's say let's say you noted this is your participants in your study. You noted their weights in kilograms. For example, let's say you found out that their weights are, say, 90 kilograms, 100 kilograms, 85 kilograms, 105 kilograms. And let's say after 3 months, for 3 months, I mean, you let them do some sort of exercise and you noted their weights again after 3 months. The same set of people, you will gather their data, their weight again after 3 months, and noted if there's a change. For example, if this person who weighs 100 kilograms before, right now, she weighs 85 kilograms. Let's say this person who weighs 90 kilograms is now 75 kilograms. If this person who weighs 85, it's now 70 kilograms. Or if this person who weighs 95 kilograms is now 70 kilograms. So you wish to determine if there is a significant difference in their weights before and after the intervention. Take note, there are two sets of data that were gathered from each of these persons. This one is no longer independent. The data is no longer independent of one another, but rather they are paired because you gather two sets of data from the same set of individuals. And hence, if you wish to compare if there's a difference before and after or a certain time after a certain time element or time frame, for example, then dependent samples t-test, or also known as paired samples t-test, can be used for such objective as long as your test necessitates the use of a parametric tool. So please read, ma'am, the introduction for this test.
The paired samples t-test is used to determine whether the mean difference between paired observations is statistically significantly different from zero. The participants are either the same individuals tested at two time points or under two different conditions on the same dependent variable. Alternatively, you could have two groups of participants that have been matched or paired on one or more characteristics, such as IQ, age, gender, and etc., and tested on one dependent variable. The paired samples t-test is also referred to as the dependent t-test, repeated measures t-test, or simply abbreviated to the paired t-test.
Okay, thank you. And for example, if you wish to understand whether there was a mean difference in the dieter's daily calorie consumption before and after a 6-week hypnotherapy program, the dependent variable here would be daily calorie consumption. And your two related groups would be calorie consumption values before and after. Then you can use dependent samples t-test to determine whether there was a mean difference in your reaction times under the two different lighting conditions. Also, take note, you gathered two sets of data from each of these individuals and compare them. Then dependent samples t-test could also uh, do the work here. Now, here are some of the basic requirements for using paired samples t-test or dependent samples t-test. In order to run a paired samples t-test, there are four assumptions that need to be considered. The first two relate to your choice of study design and the nature of your data, while the second relate to the paired samples t-test itself. The first assumption is, ma'am, please read again.
In order to run a paired samples t-test, there are four assumptions that need to be considered. The first two relate to your choice of study design and the nature of your data, whilst the second two relate to the paired samples t-test itself. Assumption number one, you have one dependent variable that is measured at the continuous level, such as ratio or interval. Examples of continuous variable include revision time, measured in hours, intelligence, measured using IQ score, exam performance, measured by 0 to 100, weight, measured in kilograms, and so forth.
If you could notice, this is also one of the assumptions of independent samples t-test. The second assumption is that you have one independent variable that consists of two categorical related groups or matched pairs. That is, a dichotomous variable. Related groups indicates that the two groups are not independent. The primary reason for having related groups is having the same participants in each group. That's why whoever take note, if you will run dependent samples t-test later on, it is important that the data that you gathered from them will be matched appropriately. For example, if you the weight before the treatment or the weight before the intervention should be matched to the weight after the intervention. The data of the participants should be matched. For example, if I it's not good to match the data of A to the data of B. No. It's AA, BB, CC, and so on. It is possible to have the same participants in each group when each participant has been measured on two occasions on the same dependent variable. For example, you might have measured 10 individuals' performance in a spelling test before and after they underwent a new form of computerized teaching method to improve spelling. You would like to know if the computer training improved their spelling performance like that. The third assumption, just like the ones earlier, there should be no significant outliers in the differences between the two related groups. The fourth assumption is that the distribution of the differences in the dependent variables between the two related groups should be approximately normally distributed as well. Normally, assumptions 1, 3, and 4 of paired samples t-test is the usual assumptions of many parametric tests. Okay, so let's have this following study designs. The first one is if you wish to determine if there are changes over time between two related groups. Just like my example earlier, let's say you measured at a certain time point, you started with your respondents, you measure let's say you wish to measure the dependent variable, say weight. Then after some time, you measure again their weight and you match it before and after. And if you wish to compare them, then dependent samples t-test may be used. Also, for the second study design, you want to determine if there are differences in the scores of a dependent variable between two related groups. In this instance, the two related groups are two treatment conditions. Okay. So we have here the different diagrams that you could actually use or refer to. Or if you wish to determine if there are differences between measurements. All right. Oh, happened. The fourth design is if you wish to determine if there are differences between matched pairs. This is especially true if you are using, say, some experiment, if you are pursuing some experimental studies involving humans. Do you have any questions so far, ma'am, or clarifications about paired samples t test?
None so far po, Doc.
Okay, if there is none, please read we as much as possible in this case. I hope you have opened the dependent samples t test practice. Okay. So anyway, please read, ma'am, the letter A, the situation.
Miss Xiao Yu, a wealthy businesswoman, would like to determine if a short lecture about business will significantly improve business knowledge of her employees. She randomly picked 20 employees. She gave a 50-item test about business to measure their knowledge about it and noted the scores. Afterwards, her staff member gave a 4-hour lecture about business. After 2 weeks, the same exam was given to the same group of people and their scores are noted as well. The test yielded an interval data determine if there is significant difference between the pre-test and post-test. Test of hypothesis at alpha is equals to 0.05.
Okay. So from here, um, so let's have your. So for our hypothesis testing, please read, ma'am, the first three parts again.
State the problem. Is there a significant difference in business knowledge of employees before and after the lecture? State HO and HA. HO, there is no significant difference in the business knowledge of employees before and after the lecture. HA, there is a significant difference in the business knowledge of employees before and after the lecture. State the significance level of alpha. Alpha is equals to 0.05.
Thank you. And this time, for the test that is for the state that test statistic part, we will now be using dependent samples t-test. If you use the term paired samples t-test or any of the equivalent terms, that is also correct. For the fifth part, the state the decision rule, it's the same for independent samples t-test. If P is less than or equal to alpha, then reject HO and report your HO. And if P is greater than alpha, then do not reject HO and you have to report HO. And now we will go to our SPSS. So in our data here, if we go to variable view, so we have here different data. So we have pre-test and we have post-test. And based on what we mentioned earlier as one of the assumptions, it is important that these two are at least interval. So that's why they have to be in scale format because these are scores, by the way. So if we click the data view, so you have here the scores for pre-test and here's a score for post-test. So take a look at the scores, ma'am. Like this person, for respondent number one, his pre-test score is 20, his post-test score is 21. For respondent number two, for respondent number seven, let's say respondent number nine, his or her pre-test is 25, the post-test score is 27, and so on. Take a look at the data, ma'am. In your opinion, do you think there's a significant difference between the pre-test and post-test score?
Um, Not really, Doc.
Okay, but again, let's do dependent samples t-test. So to do dependent samples t-test, we will click Analyze. Then go to Compare Means, and we have to click Paired Samples t-test. Okay, earlier this one, but right now we will use Paired Samples t-test and click that. So if you could see, it looks, the paired samples t-test, this one looks like this one. So we need pretest and post-test, right? So click the
Yes
pretest,
po.
then click the arrowhead towards the right. Now click the post-test and click also the arrowhead towards the right. And so it should look like this, the pre-test and the post-test. If you interchange them, I think it's still okay. Can you follow, ma'am?
Yes, Doc.
And if you are done with this, you click OK. And here is what it shows. Then I will enlarge it. It's actually part of the PowerPoint presentation. And the table looks like this. So you could see that the mean pre-test scores is 22.20. The post-test, the mean of the post-test is 22.90. Do you think significant, ma'am? I think your answer earlier was not significant, right? But let's see.
Yes, Doc.
The next important table is the last one. And just like independent samples t-test earlier, we will be reporting the T, the DF, and the sig tail. And the manner of reporting is quite similar. That is, the italicized T, and inside it, you will place there the DF or the degrees of freedom equals the T value. But for the T value here, if you could notice, we took the absolute value. We expressed it as a positive number. We disregarded the negative sign. So, and as well as we round it to two decimal places. So it's 1.97 here. I just made it positive, comma, because it's pre-test minus post-test. Um, the post-test is larger than the pre-test. That's why it gave you a negative because it's pre-test minus post-test. But if you interchange it, post-test minus pre-test, it will be positive. Okay? So that's why 1.97 comma P equals 0.064. Now, if you could notice, ma'am, di ba ito po yung p-value natin, yung sig2 tail. You could see that p is greater than alpha because 0.064 is greater than 0.05. Now, the question is, should we reject HO or not reject HO?
Come again, Doc.
Should we reject HO or not reject HO?
Not reject po.
Okay. So since P is less than alpha, then do not reject HO. Do not reject HO and report HO. That's why I copied the null hypothesis earlier. And for the formulate conclusion part, thus, there is no significant difference in the business knowledge of employees before and after the lecture. And having another interpretation, this implies that business knowledge before and after the lecture or intervention are similar or comparable. All right, let's proceed to another example. Please read it again, ma'am.
Miss Xiao Yu invented Shishi pill that she believes could potentially reduce weight. She randomly chose 20 overweight women and noted their weight in kilograms before the intervention. For the intervention, the participants took the pill 30 minutes before bedtime and they continued with their habits and diet. After 3 months of taking the pill, Miss Xiao Yu noted their weights again. Determine if shishi pill is effective or not at alpha is equals to 2.05. Note that for this context, shishi pill is effective if the weight after the intervention is significantly lower than the weight before the intervention.
Thank you. And for the problem, is there a significant difference in the weights of obese women before and after the intervention? For the HO and HA, there is no significant difference in the weights of obese women before and after the intervention. That's your HO. Our HA is there is a significant difference in the weights of obese women before and after the intervention. The significance level is still 0.05 for our class, for our case, I mean. For the test statistic, we will use dependent samples t-test. And for the decision rule, it's the same. If P is less than or equal to alpha, then we check HO and report HA. If P is greater than alpha, then do not reject HO and you have to report HO. So I believe we are now ready to do our paired samples t-test. Let's go back to our file again. And remember, in this case, we will have their weight before and weight after. Take note that it's understood that the respondent number one's weight is 103.55 kilograms before, and after the intervention, it became 85.00, and the rest is same for each of these participants. Now, in your case, ma'am, tingnan po ninyo. Look at their weights before and after. Do you think they're significantly different or not?
Yes po, Doc. Medyo
Okay,
malaki ang difference.
medyo malaki. So you're claiming na parang significant siya. Let's see if you are right. So again, ma'am, what do? We go to analyze, then,
Compare means,
then,
and then paired samples t-test.
okay, thank you. So clicking on this, you notice, as what I mentioned also earlier, the previous test, if you are using the same test and you have encoded their previous data, it SPSS remembers. So we don't need this too. So place it back there. I need the weight before the intervention. So click it here. And we have the weight after the intervention and also click it towards here. All right. Then click OK. And this is your results. You see, we have three tables, but I will need only the first and the third table for now and report them in this manner. So the mean weight before the intervention is 102.3080. And the mean weight after the intervention is 86.5560. Parang ang layo, no, ng difference. Parang malayo nga.
Yes po.
But again, so gusto ko ito, no? Gusto ko rin pumayat. Char lang. Okay. So, if you could see from here, the last three which I highlighted are the important ones. And again, the manner of reporting is T. Inside the parentheses, you place there your DF, which is 19, equals. The value of T, this 8.699, when rounded to three decimal places, is 8.70, comma, your sig2 tail, which is your P, 0.000. And 0.000 is less than your alpha, so P is less than your alpha. Now, should we reject HO or not reject HO?
Not reject HO, Doc.
Reject or not? Ulit po.
Not reject po.
So if we could see po, kung less than siya, ano po yung nakastay? It says reject, no? So reject po tayo ba?
Yes po,
We,
Doc.
we will
Opo.
not, so be careful po. So since P is less than alpha, then reject HO and you have to report and interpret your HA. That's why I copied the alternative hypothesis earlier and I had this as my conclusion. Thus, there is a significant difference in the weights of obese women before and after the intervention. Take note, if there's a significant difference, I wish that you should report which one is significantly lower or significantly higher or whatever interpretation appropriate for the data. For this case, since the mean weight after the intervention is less than the mean weight before the intervention, then it can be said. And if you could see also from the data that the weights are actually less than their weight before, then it can be said that shih pill is effective in reducing body weight. All right, and that concludes our presentation for dependent samples t-test. Thank you so much and a great day to one and all.